Just like whole numbers, fractions can be composed and decomposed, added and subtracted. Fractions and whole numbers follow the same thought process and are just more numbers on the number line. And I know I keep saying that, but if students are to understand that they're just like any other number, they're not to be afraid of them. So reiterating that is super important to me. Derek decides to start working on his sand designs. He has 4 1/3 cups of purple sand to use. First, he puts 1 1/3 cup of purple sand in one jar. How much purple sand does he have left? Next, he puts 1 2/3 cup of purple sand in a second jar. How much purple sand does he have left now? So we'll start on a number line. So on my number line, I have 1, 2, 3, and 4. And not only that, but they're split into copies of 1/3. So I start at 4 copies of 1/3. That's what we started with. First, he puts 1 1/3 cup of purple sand in a jar. How much does he have left now? So now we need to subtract 1 1/3. So I count over to the left, so subtract. I take away 1 copy of 1/3, which brings me here, and now I take away a whole unit, which brings me to 3. Further, so now he has 3 cups left. Next, he puts 1 2/3 cups of purple sand in a second jar. How much purple sand does he have left now? So we're starting at 3, and we need to take away 1 2 copies of 1/3. So if I were to go from 3 to 2, that would be 1, and I need to take away 2/3 cup more. So 1 2/3 cup more, leaving me at 1 1/3 cup. So we just did an example looking at what we call mixed numbers. I just want you to call them fractions because again, they're just like any other number on the number line. Let's decompose 2 1/4 to show that it must be the same as 9/4. In both of our fractions, notice that we have copies of 1/4 that we are looking at. So when I start at 2 1/4, I need to count over from 1, since it was blank over here, 1, 2, 3, 4 copies of 1/4, which would give me another whole. And then this other new one next to it, the other line would be 2 1/4. Let's see if we can show that that is the same as 9 copies of 1/4. So if I know from each distance is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4. So 9/4 is 9 copies of 1/4. I hop over 9 times, and sure enough, I land at the same location. Harry walked 1 5/6 miles to the beach, then another 5/6 of a mile to the store, and then 1 2/6 miles home. How many miles did Harry travel altogether? We know that to add them all together, we can decompose our numbers. So here we're adding all of our miles together so that we can show how many we did all together. And what I've done is taken my whole number pieces and rearranged them and separated them from the fractional pieces. I also know that 5/6 plus 1/6 would give me 6 out of 6, which is a whole. So what I did was decomposed 5 copies of 6, the second one here. I gave 1 copy of 1/6 here, and I broke this into 4 copies of 6 over here. So 5/6 plus 1/6 would give us 6 copies of 1/6, which we know is a whole, and 4 copies of 1/6 plus 2 copies of 1/6 is also 6 copies of 1/6, so another whole. Adding all of my whole pieces together, I see that Harry walked 4 miles. Fractions and decimals can be written in different forms. So let's start off by saying that we have 7 pennies. We know it takes 100 pennies to make $1. $1 is the unit. We can say that 7 out of 100 is what represents the amount of pennies we have. When looking and using a hundredths chart or a flat, this also means that 7 out of 100 units are highlighted. We say this is 7 hundredths. Now let's say we have 3 nickels and 4 pennies. This is 19 cents, or 19 out of 100, so 19 hundredths, and 19 of the 100 are shaded in our base 10 flat. This is written as 19 hundredths. Now we have 2 $1 bills, 3 nickels, and 4 pennies. In fractional form, this is 2 and 19 hundredths, meaning that 2 full base 10 pieces would need to be, for our unit, would need to be colored, and 19 more of a third one, so a portion. This is 2 and 19 hundredths. Now we have 3 quarters and a nickel. If we were to count, this would be 80 cents, so 80 hundredths. So 8 out of the 80 of the 100 units would be highlighted. Further, this is the same as 8 tenths, since 8 full ones are done. So we could also say that there are 8 out of the 10 highlighted. We can extend the idea of decimals using base 10 models with any decimal, such as representing 1.42 meters. Represent 1.42 meters as a fraction and using base 10 models. As a fraction would be 1 and 42 hundredths. So 1 full base 10 block flat would need to be there, plus a portion of a second one, particularly 42 little units highlighted. Write 24 hundredths as a fraction and as a decimal. Use a place value chart to explain how they are connected. 24 hundredths is written as 24 over 100, meaning that there are 24 squares out of 100 colored in. When I look at my place value chart, 2 is in the tenths place and 4 is in the hundredths place, which is how we get 24 hundredths. The last number in the decimal indicates how we're going to say the decimal. Which letter best represents the location of 54 hundredths? Well, I can look at 5 tenths here, or 50 hundredths, and count 4 more, 1, 2, 3, 4. So it appears that C would be the best letter. What about 88 hundredths? So looking at my number line, I first want to tackle and say that this is 80 hundredths, or 8 tenths, and count over 8 hundredths more to get to letter E. Homework. Print the practice worksheets provided in the Practice Fractions homework Dropbox. Complete the assignment, scan, and upload back into the appropriate Dropbox.